Hi guys, this is the explanation for 13.4. This is the memo if you didn't understand anything. Alright, so we had to classify the shape based on what they told us on the diagram. So the first one for D, they say the opposite sides are equal. That's the only thing they tell us. They say there's two pairs of opposite sides equal. That is true for a rectangle and a parallelogram. But they don't tell us that the angles are equal to 90 degrees. We don't know what the angles are equal to, so we choose parallelogram. So NOPQ is parallelogram. If I want to see what it looks like drawn to scale, there it is there. You don't need to draw it to scale in your books. You just need to classify it and give me the reason for the classification. Right, E, they tell us the opposite angles are equal. Okay, the opposite angles are equal and not all the angles are equal. So those two are equal to each other, and then R and T are equal to each other. So they can't all be equal to each other. So what can I conclude? I can conclude it's a parallelogram. Okay, I know that the opposite angles are also equal to each other in a rhombus, but they didn't tell me anything about the sides being equal to each other, so I don't choose rhombus. What does it look like to scale? Okay, it's parallelogram again, so it's just the same as D. In F, they tell me only one thing. They tell me that there's one pair of parallel lines. Okay, the only shape that has one pair of parallel lines only is a trapezium, so that's what I classify it as. And what does it look like to scale? There we go. Right, G. Okay, G, they tell me a few things. Okay, so the first thing they tell me is that the diagonals intersect at 90. Okay, so diagonals are these lines in between the shape here. They intersect at 90 degrees. Okay, so the only shapes that happens with is a kite, a rhombus, and a square. So it could be either of those so far. They also tell me that the diagonals the diagonals are equal to each other. Okay, so they're equal to each other and they bisect each other, so they cut each other in half. We conclude, therefore, that it's a square because that's the only shape where all of those things happen. And if I look at that to scale, that's what it looks like. Alright, then for H, what do I know about H? Okay, the only thing I know about H is that the diagonals are equal and that they bisect each other. Okay, so they haven't told me that there's a 90-degree angle there. And because I don't know that it's a 90-degree angle, I can't say that it's a square. But there is a shape where the diagonals are equal and bisect each other, cuts each other in half, and that's a rectangle. So if you have a look at what it looks like to scale, it looks like this. Okay, so there it is, but there's no 90-degree angle in the middle there because that would make it a square. And then the last one that you had to do for homework was I. Alright, for I, what do we know? We know that the opposite angles are equal. Okay, so opposite angles are equal. Not all of them are equal, only the opposite ones. Okay, so it's definitely not a square or a rectangle. We also know that the diagonals bisect the angle. So these lines in the middle, they cut the angle in half. Okay, and what can I conclude then? I can conclude that it's a rhombus. Okay, because that's what happens in a rhombus. And then if I look at it to scale, there it is to scale. So those two are equal to each other, just like Y and Y were equal to each other. There the blue angle and the blue angle are equal to each other.